talk about community storage using Lustre and Globus Sharing. So what is this? ALCF provides HPC resources through a competitive allocation process. Projects have collaborators across government, academia, and industry. ALCF has external users, meaning the user would like to share data with other collaborators. And old method of sharing required ALCF accounts to create that, and collaborators added to as full project members. And it's not convenient because then they can run jobs, but that may be not desired by PI. And it's also cumbersome for users. So it's not only convenience and desire, but it also a requirement because DOE funded projects now required to follow FAIR principle, which includes the data are findable and accessible. So ALCF Globus Sharing helps scientists achieve ability to provide findable and accessible data. ALCF Systems. So our main system at this point is Polaris. It has CPU and GPUs. It consists of 560 compute nodes, which are AMD Milan, and each node has 4 NVIDIA 100 GPUs. SETA machine is CPU only. This is KNL. It has almost 4,400 nodes, Xine machine. So couple years ago, we added SETA GPU machine, which actually part of the SETA, and they have a common scheduler. When you submit PBS job, you can specify where it runs on SETA GPU and or KNL. It has 24 nodes. Each node has 2 CPUs and also 8 NVIDIA A100. So that was machine where we learned how to work with NVIDIAs, and Polaris was next machine. Kuly is old visualization cluster which used for SETA. It has GPUs, NVIDIA Tesla K80, so data which were processed on SETA can be visualized. You can see the data on Kuly. So there are several novel machines that is AI testbed, and so it's new various AI accelerators. So several of them are available for allocation through director's discretionary spending, and that system are Cerebras CS2 and Samba Nova Datascale. So last week, GraphCore MK1 became available for scheduling, and we're still working on Grok and Habana Gaudi machines. So Polaris, as I said, is our major computational resource right now, and it provides ramp up to Aurora. Allocations available through Insight, ALCC, and direct allocations. Aurora, our future exascale system, it currently been installed. It has above 10,000 nodes. Each node has 2 Xine CPU Max series processor, and also it has 6 Intel data center GPU Max series GPU. If you look on picture, it Ponte Vecca, but they renamed it. So Aurora resides on Slingshot 11 fabric. Each node has 8 fabric endpoints, and everything connected through HP Slingshot 11 in Dragonfly topology. So each switch has 64 ports, 200 gigabits per second each. There are inter-switch connection, there are downlink to nodes, and there are uplinks to connect group of switches. So the main file system for Aurora will be DAOs. It will have more than 230 petabytes, and we plan to achieve rates 25 terabytes per second. So this is system architecture, and it's shown here network-centric. So we have InfiniBand HDR fabric with 200 gigabit links. And if you look to the bottom, you will see Eagle file system. This is a community file system which we share. And on to the right of it, there is DDN and data transfer node, which allows access through ESNet. So we have several other clusters, SATA GPU shown, old SATA machine, which resides on Aries network. Kuli is directly connected to InfiniBand, but that is InfiniBand FDR, which connected to HDR fabric. So on the left we have Polaris. It connects. It resides on Slingshot 10. We plan to upgrade it to Slingshot 11, and it connects through 50 gateway nodes to fabric. Aurora been installed. It has Slingshot 11, and DAOs resides directly on Slingshot 11 network. To access that from Aurora file system, there are 100 gateways, and right now we have small 14 petabyte DDN servers installed, which called Gecko. So we can access all file systems through DDNs, but we do community sharing only for Eagle file system. Eagle file system is HP cluster store E1000. It has 100 petabytes of usable capacity, and I/O rates are above 650 gigabytes per second on InfiniBand network. Total 8400 HDDs. There are NVMe drives used for metadata and also for write logs. The system composed of 10 racks, and this is usual configuration. So overall we have 20 MDS and 40 OSS, and from storage side it's 160 OSTs and 40 MDTs. So it's only 8 racks shown on this picture. Software, we have Neo 4.5 HP stack, and it provides Lustre to 12 on servers. We plan to upgrade to next release of Neo 6.2, maybe 6.3 if it gets available, and that will give us Lustre 215 on servers. We use everything connected through 200 gigabit network. We use LDiskFS based OSTs. We use project quotas and DNE1. So on the right, there are results from Polaris acceptance testing and that test. So we accepted Polaris earlier, but that specific test ran last fall, and this is the test was running against grain file system, which totally equivalent to Eagle, and performance is the same. So test ran on almost all compute nodes, 512 out of 560, and used almost all OSTs. Total is 160. So results are 366 gigabytes per second write, read is 270, and shared file has some smaller values. So it does not hit full bandwidth of the available from file system, but for this test we used only 32 gateways because due to supply issues we didn't have initially all required cables. Now we do and can configure all 50 gateways. And the other limitation comes, system initially was deployed with Slingshot 10. We have Rosetta switches, but on compute node side, it's Mellanox card. So we plan to have upgrade to Slingshot 11, and so right now the limitation is 100 gigabit per second. After upgrade to Cassini card, it will be 200. Globus. Globus, I'm not expert in Globus, and over here there are many people who know this stuff much better than me. Globus service that provides research data management, including managed transfer and sharing. It makes easier to move data, and this utility enables efficient data transfer between major LCF data sensors and also to get data on your laptop. Globus sharing feature, it provides the ability to share data with other users even they do not have account on system where the data resides. Data on ALCF system can easily be shared with collaborators who are LCF at LCF or elsewhere, and PI has full control what data he can share and what extent of access will be provided. So PI also can choose to share data to all authenticated Globus users or make access public, but in case of public access, it's read-only. Public cannot write to the system. Transfers controlled through Globus file manager residing on globus.org. And also it's possible to have direct browser access to data, or if you copy URL, you can copy it. Here's illustration how PI can start sharing data. So it's probably doesn't, it's small, sorry. So here can choose Eagle DTN endpoint, then specify directory which will be shared, and it resides on the top of the file system tree, and click button create connection. Next step will be to specify extent of sharing, so it's project subfolder only in this case, and on next menu it will be choose how wide that data going to be shared. PI can select user group, all users, or make it public, but when it's you want to share public write, you cannot do writes. Data transfer node. There are 4 data transfer nodes. Each has 64 cores, external network connectivity through 2 bonded 100 gigabit interfaces, And on InfiniBand internal network, it's 200 gigabit HDR interfaces. We have standard for us Lustre client, Cray Lustre client 212. Currently it's version tag B58. We performed tuning of TCP side according to ESNet guidelines, which includes setting TCP buffer size to maximum, set CPU governor to performance, disable IRQ balance, and specify affinity. Globus endpoint configured to allow maximum 96 files in flight per transfer, and it may have 16 parallel network streams per file. Globus Setup. Globus web-based application operated by globus.org. Sites maintain endpoints which consist of data transfer nodes. Endpoint can host multiple collections which are essentially views of specific file system. There are map collection, and we on Eagle configured user may create their own guest collections, which provide shared access to non-LCF users. We run Globus Connect Server version 5.4. All LCF project members can access their project directly via endpoint LCF DT and Eagle collection, but only PI for the project is allowed to share data, and he is only allowed to share his own project. Guest collections are tied to PI account and rely on account remaining active. So if PI left, everything is closed. Direct HTTP access to collection is enabled, and it allows direct download of files using web browser. UDT is available as alternative transport, and it can improve performance for high delay network paths. LCF had Globus to add several new features to support Eagle use case. One first feature was to have fine-grained sharing policy to ensure PI can only share from their own project directories, extra layer of security on top of file permissions. The option to administratively prohibit write access to anonymous sharing. So there are considerations during that project implementation. Eagle is mounted on all compute nodes, which facilitate I/O when written directly to shared directories. You don't need to do anything special, you just write to that directory. And it provides easy method to share data with no need to copy or have duplicate data. No need to keep data synchronized, and it saves time and space. Consequently, all project members can read-write data into directories based on common Unix group used by project, but here we need to be careful because PI can share a folder with some data, and if member of the project writes some data to that directory, it becomes available to everyone or people whom they share. So one of the use cases for the system was Earth System Grid Federation, ESGF, which is now in stage 2. They produced files, large data sample for Earth system model simulation data, and I believe they were initially generated at Livermore. So last year, from mid-February to beginning of May, there was data transfer of this data from Livermore to ALCF, and also the other stream of data was sent to Oak Ridge, and that was different parts of the data sample, and there also was stream of data between Oak Ridge and ALCF. So performance in the average, and it included different delays and other stuff. It was 1.5 gigabyte per second between Livermore and LCF, and about 5 gigabytes per second between ILCF and Oak Ridge. So 11 million files transferred, and data size is about 8 petabyte. Eagle has 100, so it's substantial fraction of data storage we use. The other example is automated APS workflow with on-demand computing, and this is what has been done pretty much recently. It can be involved to describe that. I will try. So if you look on picture on the bottom, there is a ring, which is APS. It's advanced photon source, which generates high-intensity X-rays used to study materials and many other things. We are currently doing upgrade of the ring, and intensity of the ring will be higher, factor of hundreds, probably 500. So it will be just very special device for material study. So on the right, we have Polaris, which is high performance top rated HPC cluster, and it will be beneficial to process data delivered from accelerator directly through Polaris. So there are many beams on this accelerator, and different experiments, variety of applications. They have APS data management framework which collects data. So what was accomplished recently, we connected APS data management structure through Globus to Eagle computer. So as soon as some data received, they get pushed automatically. All this process automatically works automatically without human intervention. Data get pushed to Eagle and stored on that file system. And at that time, data processing framework triggers and starts the job on Polaris file system. That job has high priority, and it can suppress other background jobs. Polaris can process that image and can generate image from processing data, whatever experiment wants, and drops results back to Eagle. And at that point, data get available, and the scientist can decide, do they want to continue experiment with the same parameters or change something and adjust. And so it's feedback loop, and everything is automatic, and people can see what they do in real time. Conclusion: we provided high performance Lustre based parallel file system. It's center-wide, supports checkpoint I/O, analysis I/O, input data code. It's POSIX compliant. For grid sharing, it enables scientists to share data produced with collaborators or the public. There is minimal overhead, no requirements for LCF accounts or project membership. Efficient data transfer provided via Globus and Globus endpoints. And we enable scientists to implement FAIR principles for data generated from DOE science. And acknowledgement.
Any questions? I have two. So
Yes.
what happens down the road when you have Aurora operational? Will that Eagle point be replaced with Deos and Polaris will be replaced with Aurora in this one?
We can do that. We can do that. So on network, it's like everyone connects to HDR InfiniBand, and Aurora will mount Eagle.
Yeah,
and
but
Grand.
if you want to process on Aurora coming from the beam line,
Right.
you will write first to Eagle, then transfer Eagle from Deos for Aurora to
No. It's okay. So on that picture, we saw we can drop data to Eagle, so it will be over there, and then you trigger batch job, and because Eagle already mounted to Aurora, it's not mounted today, but like sometime down the road, Aurora can start the job and do the same stuff.
So yeah, okay, I got what you mean. So there's no point you are thinking replacing Eagle in this process and directly dropping data to Deos for Aurora to process. Eagle will always be there for data to be staged then.
Right.
Okay.
Yeah, so Eagle is HDD as Grand, right? I'm not talking about MGTs. So SSDs connected, DAOs is our SSD system, right? And it's directly sitting on Slingshot. So for small IOs and all the stuff, it will be DAOs. But you need to modify applications to use that API to work with DAOs.
Okay.
So you need to, and not everyone will be able to do that. Okay. So we do plan that we will mount Grand and we'll mount Aurora as usual file system, but do not expect the same response like for small files because it's HDD.
And this is not streaming data we are talking about. This is file-based store and forward type data transfer, correct?
Right, it's Globus.
So there's no streaming, okay.
Yeah.
Okay. See? Questions?
Hi there. Very convenient you have that slide up. Is there anything sitting between your HDR 200 and your FDR InfiniBand fabrics, like LNet routers or anything like that? Or
No.
Directly connected?
Directly connected. We have a limited number of links, it's like 18 links, but that is because of dual port count, and that is why that path, we have some constraints on rates from SATA to Eagle Grand.
And no issues with that, because it's not supposed to be supported, as far as I'm aware?
It's whatever networking people do. So there are no Lustre gateways.
Okay, well, we threw EDR in between those two networks, so it is possible, but it's not supposed to be supported.
Thank you. Hello. My name's Louise. I'm with Starfish. Do you mind going back to the slide of the automated workflows? Yeah, so I got the pleasure to talk to one of your colleagues, John Hammonds, I believe is his name, at Globus World last week. And I think it's really cool everything you guys are doing with your data management system. And we've gotten to some details about, I like the way you guys have set it up where you do it on an experiment basis. However, my question was, it seems like, are you storing information in your data management system about the jobs and the jobs that were, the transfers that were performed, or is that versioning history and that historical data really just stored in Globus? Do you know what I'm saying? Like, is it cyclical? Do you store information about what you've done to files in your data management service, like back into that? Especially if you just created a copy of that file?
I'm not sure about that, but there is link from Eagle, and results go to APS data management.
You are
Two.
asking about data provenance, right?
Yeah, I'm trying to understand, because I know they have, like, you guys have a database somewhere in this system that stores information about the files associated with certain experiments, and I assume that based on the experiment ID, you know, that's what you're using to reference certain files. So I was just trying to understand, how you're storing information about what actions were done, or if you are. But
Unfortunately, I do not know much details. So APS-DM, it was separate system. And on the right and on the left and on the right there is PBS system, and so they kind of connected that together, and I'm sure that they should keep track what data was sent and was it processed or not, and what is the state.
I see. Thank you.
Probably done in APS. Any other questions? Why will you ask a question? So I have to walk around. Efficient Globus.
You're welcome.
I will have to direct questions to Kevin.
Thanks, Alex. So I also do Globus on the Livermore side, and our endpoint is fairly old hardware. I'm surprised how large your community file system is hooked up to Globus, and wondering how much data are you moving? Do you need, 100 petabytes? You need 50 petabytes, 20 petabytes? How much? Do you have any idea of how much data you're moving each day through Globus?
No, I don't. So I was watching this transfer when it was happening, and again, that 8 petabyte data moved from Livermore to LCF is substantial fraction of our storage. It's just one data set, right? 8 out of 100, and so.
Yeah, I remember working with Eli and others trying to get that faster on our side. So thank you.
Hey, if you want to store something, come to our site. We have ample storage. Any other questions? This is a glimpse of the future. This is not something unique. DOE labs, if you are not aware of it, are working hard behind the scenes to enable an integrated research infrastructure for the future. So these type of talks you will see more often. These type of connections you will see more often. These type of data transfers you will see more often coming down the road. I'm just giving you all heads up. Okay.
Thank you.
Let's thank our speaker. Thank you.